You know that feeling, right? That tickle, the sneeze is hitting you the second you step outside.
Yeah.
Seasonal allergies, yeah, we all know them.
Mm.
But what if? What if climate change is making it all worse? Not just like a bit worse, but way worse. Longer seasons, more intense pollen, maybe even these really extreme allergy events.
That's exactly what we're diving into today. We're looking at this BBC article that really lays out how our changing climate is, well, it's supercharging pollen. It's making life tougher for allergy sufferers.
Right.
So our mission, if you will, is to unpack the science behind it, to understand how rising temperatures, CO2, all that stuff is messing with pollen and what it means for, well, for you if you get hay fever.
Okay, let's kick things off with something pretty dramatic. Melbourne, Australia, November 2016. This thunderstorm asthma event. Sounds almost made up, but it was very real.
Oh, absolutely real. And catastrophic. The article describes it vividly. I mean, imagine the emergency lines just completely swamped. Hospitals suddenly seeing 8 times the usual number of people with breathing problems. Asthma admissions nearly 10 times higher than normal. It was, yeah, unprecedented.
And tragically, people died.
Yes, 10 people lost their lives, including a young person who was waiting for an ambulance that just couldn't get there fast enough. The system was overwhelmed.
That's just awful.
Mm.
So what exactly is thunderstorm asthma? How does a storm cause asthma attacks on such a massive scale?
It's a really frightening phenomenon. The theory goes like this. A big thunderstorm, particularly the downdrafts, the cold air rushing down,
Right.
It kicks up huge amounts of pollen from the ground, ryegrass pollen in Melbourne's case. Then the updrafts suck this pollen high into the storm cloud.
High up into the clouds.
Exactly. And up there with all the moisture, the humidity, the pollen grains absorb water, they swell up, and then they rupture, they burst.
They burst. Into what?
Into tiny, tiny fragments, hundreds of them from each grain. And these fragments are loaded with the allergenic proteins.
Ah, so it's not whole pollen grains raining down. It's these super fine, super concentrated allergen particles.
Precisely. And because they're so small, you breathe them in much deeper into your lungs than you normally would with whole pollen grains.
Which triggers a much worse reaction, I guess.
There's more severe reaction, yeah. Even potentially in people who only have mild hay fever usually, or maybe even just asthma triggered by exercise. The article quotes a survivor. She said she went from fine to gasping for air in maybe half an hour.
Terrifying. And this scientist mentioned Paul Beggs. He studies this.
Yeah, Paul Beggs, an environmental health scientist. He recalls the event, how even the hospitals were initially just stunned by the sheer volume of people needing urgent help.
And Melbourne's had these before, but this one was worse.
They've had 7 major ones since 1984, apparently, but 2016 was by far the worst. And it's not just Melbourne. Similar things, though maybe less intense or rarer, have happened in the UK, in the US. Birmingham, Atlanta are mentioned.
So how does climate change fit into this nightmare scenario?
Yeah.
Beggs links it.
He does. His research, including a paper just out this year, points to climate change as a likely contributor. It's sort of a two-pronged thing.
Okay.
First, as we'll get into more, climate change is making pollen seasons longer and more intense. So there's just more pollen around to get sucked up into these storms in the first place.
More fuel for the fire, basically.
Exactly. And second, climate change is also linked to an increase in extreme weather events, including potentially the kind of severe thunderstorms that can trigger this. So more pollen, potentially more trigger events.
Right, that makes sense. It's like loading the dice for these kinds of disasters.
Biggs is careful. You know, you can't pin one single event entirely on climate change, but he's reasonably certain it played a role in making the 2016 Melbourne event so severe.
Okay, so let's unpack that thunderstorm mechanism a bit more. You mentioned the downdrafts kicking up pollen, the updrafts carrying it up, the moisture making it rupture into these tiny, deep lung-penetrating particles. Is there anything else going on in the storm?
Well, the article also mentions the possible role of the storm's strong electric field. That might also contribute to breaking the pollen grains apart. It's complex, still being studied, but the main idea is that rupture due to moisture.
And the timing is crucial too, right? Like it happens really fast.
Yes, studies show pollen levels, or rather these allergenic particles, can spike dramatically in the first 20 to 30 minutes of one of these thunderstorms, and it seems younger people might be particularly vulnerable.
A really sudden, intense exposure.
Exactly. And while thankfully these major thunderstorm asthma events are still rare, the concern is that climate change, by lengthening pollen seasons and maybe increasing storm severity, could make them, well, less rare.
A worrying thought. Okay, let's shift gears slightly from the extreme events to the more everyday impact. Longer, more intense pollen seasons. This seems to be a key effect of rising temperatures.
Definitely. Elaine Fortes, a public health scientist mentioned in the piece, she explains it simply. Warmer temperatures mean plants start producing pollen earlier in the spring and continue later into the autumn.
So the misery just lasts longer for allergy sufferers.
Pretty much. You're looking at potentially weeks or even months more of symptoms each year compared to, say, a few decades ago.
And the article highlights ragweed as a big offender. One plant making 1 billion pollen grains.
It's staggering, isn't it? Ragweed is incredibly potent and widespread, especially in North America and increasingly in Europe. It already affects millions.
And the data shows the seasons are getting longer.
Oh, clearly. The article cites work by Louis Ziska, another environmental health scientist. He looked at North America between 1995 and 2015. In Winnipeg, Canada, the ragweed season got 25 days longer.
Wow, nearly a month.
Yeah. Fargo, North Dakota, 21 days longer. Minneapolis, 18 days longer. These aren't small changes.
No, that's significant extra time feeling unwell. And this is happening more in certain areas.
It seems the effect is more pronounced in northern latitudes, also in Australia, parts of South America, Africa, places where the temperature changes are having a bigger impact on plant growing seasons.
And looking ahead, the projections are.
Not great, frankly. A study from 2022 projected that by the end of this century, pollen seasons could start up to 40 days earlier
40 days.
and end maybe 15 days later. Add that up, and you're potentially looking at almost 2 extra months of pollen exposure for hay fever sufferers each year.
That really changes the picture of seasonal allergies, doesn't it? It becomes almost a year-round thing for some people in some places.
It certainly could head that way.
But it's not just about the length of the season, is it? The article also talks about the amount of pollen increasing because of CO2.
Yes, that's the other major factor. It's not just a longer window, it's more pollen during that window.
How does that work? Plants like CO2.
Many of the plants that cause allergies, yeah, they thrive on higher CO2 levels. It's like plant food for them. The article points to research showing that back in the 2000s, the U.S. pollen season was already starting 3 days earlier than the 90s. But the total amount of pollen had jumped by 46%.
46%? In just one decade. That's huge.
It is. It shows how sensitive these plants are to atmospheric CO2. More CO2 means more growth and, crucially, more pollen production.
Are there specific experiments showing this?
Oh, yeah. They've done controlled experiments. For instance, growing grass at 800 parts per million CO2, a level we might hit later this century if emissions aren't cut drastically.
Right.
That grass produced about 50% more pollen than grass grown at today's levels, around 400 ppm. Oak trees showed even more dramatic results in some studies, like 13 times more pollen at very high CO2 levels compared to pre-industrial levels.
13 times. That's almost unbelievable.
It is a massive increase. Even at more moderate future CO2 projections, the increases are significant.
And Louis Siska's work on ragweed showed this too. More growth, more pollen with more CO2.
Exactly. His experiments confirmed it for ragweed. And he also raised another worrying point. The pollen itself might become more allergenic.
Wait, what? More potent?
Potentially, yes. The proteins in the pollen that actually trigger the allergic reaction in us. Higher CO2 might cause the plants to produce more of those, or maybe slightly different versions that are more irritating to our immune systems.
So longer seasons, way more pollen, and that pollen might pack a bigger punch. That's quite the triple threat.
It really is. It helps explain why allergies seem to be getting more severe for many people.
Okay, another angle the article brings up is invasive species. Plants moving into new areas because the climate is changing.
Right. Climate change allows plants like ragweed, which is originally North American, to establish themselves and spread in places like Europe, Australia, Asia, South America.
And when a new plant like that arrives,
People who've never encountered its pollen before start getting exposed. And because they haven't built up any kind of tolerance, they can develop new allergies, new sensitivities.
the article gave some figures for ragweed sensitivity in Europe. Hungary, Denmark, the Netherlands. Pretty high percentages.
Yeah, 60% sensitivity in Hungary, 20% in Denmark, 15% in the Netherlands. That shows how quickly a population can become sensitized when a new potent allergen arrives and spreads.
And the projections for ragweed in Europe are bad.
Very concerning. The article mentions estimates that ragweed pollen concentrations could potentially quadruple by 2050 in some areas. Even places where it's rare now, like southern UK or Germany, could see significant levels.
Quadruple. And why such a big increase? Is it just the plant spreading, or is climate change involved there too?
It's both. The analysis suggests about one-third of that projected increase is down to the plant simply spreading to new areas. But two-thirds
Two-thirds.
is directly due to climate change making conditions better for it, especially the longer growing season we talked about.
So climate change is both helping it spread and making it produce more pollen once it gets there.
Exactly. As Elaine Fortes puts it, it means earlier, longer, more intense seasons and new people getting sensitized. It's a global issue.
Now, it's not all uniform, though. The article mentions regional differences.
That's a fair point. Climate change impacts aren't the same everywhere. While the general trend is towards worse pollen seasons, some specific regions might see different effects.
Like where?
Southern California, for example. It's prone to drought, which might also be linked to climate change. Some studies suggest that less rainfall there could lead to earlier pollen seasons, but maybe less productive ones overall. So the timing shifts, but the total amount might not increase as much or could even decrease in severe drought years.
So it depends on rainfall patterns, too, not just temperature and CO2.
Right. And the article also briefly touches on wildfires. More frequent wildfires, another climate change consequence, obviously worsen air quality and can trigger asthma and allergy symptoms, but that's more about the smoke and particulates than the pollen itself.
Okay, so it's complex, but the overall picture seems pretty clear. Mostly worse for allergy sufferers. This sounds pretty daunting. What can actually be done? Does the article offer any solutions?
Well, the big one, the fundamental one, is cutting carbon emissions. Addressing the root cause, climate change itself, that's paramount.
Obviously. But are there more direct things we can do about the pollen itself?
Yes, and there are historical precedents. The article mentions Chicago back in the 1930s. They had these ragweed commissions.
Really? What do they do?
They basically organized efforts to find and destroy ragweed plants across the city, and estimates suggest they might have cut local pollen levels by about 50%.
Wow, that's impressive. So targeted removal can work.
It can make a difference locally, yeah, though it's labor-intensive, obviously. But similar efforts are happening now. Berlin has a program to remove ragweed. Switzerland has actually banned the plant and relies on volunteers to pull it up where it appears.
So community action, government programs. What about, like, city planning? Planting fewer allergy-inducing trees.
That's definitely part of the conversation. Smarter urban greening. Thinking about the allergenic potential of plants before putting them in parks and along streets. Avoiding species known to cause problems.
I've heard about this thing called botanical sexism, planting mostly male trees because they don't drop fruit or seeds, but they produce tons of pollen. Is that a big factor?
The article mentions it, but suggests that while it might play a small role in some cities, it's probably not a primary driver compared to the huge impacts of climate change overall and the spread of things like ragweed. So yes, better tree selection helps, but it's not the whole solution.
Okay. What else? Monitoring. Knowing what's actually in the air.
That seems absolutely crucial. Paul Beggs is quoted saying we fundamentally need to know what we're breathing. We track temperature, rain, pollution, but detailed, real-time monitoring of specific airborne allergens is often lacking.
Don't we have pollen counts?
We do, but they're often based on models, or they just count total pollen grains, not necessarily the actual amount of allergenic protein in the air, which can vary. Elaine Fuerte's research shows that these allergen levels are much more closely linked to people's symptoms than simple pollen counts.
Ah, I see. So we need better, more specific measurements.
Exactly. Moving towards routine measurement of actual allergen levels could give people much better warnings and allow them to take preventative measures more effectively, knowing when the specific things you're allergic to are peaking.
That makes a lot of sense. Better information leads to better management. Okay, so let's try and wrap this up. If you had to boil down the key takeaway from this deep dive into climate change, pollen, and allergies, what would it be?
I think the clearest message is that climate change isn't just some abstract future threat for allergy sufferers. It's demonstrably making things worse right now. We're seeing longer seasons, much higher pollen counts driven by CO2, invasive plants causing new problems, and the frightening potential for more extreme events like thunderstorm asthma. And the expert consensus seems really strong. Unless we tackle emissions seriously and also implement smart local strategies, better monitoring, targeted plant management, these trends are just going to intensify. Life is likely to get much snifflier, unfortunately.
A rather sobering conclusion. It definitely puts those seasonal sniffles in a much broader and, frankly, more concerning context. So, a final thought for everyone listening. Considering all this, the longer seasons, the supercharged pollen, the risk of extreme events, how might you look at your own local environment differently now? What about your daily routine during allergy season? Maybe worth thinking about what's in the air around you and how it might be changing. Definitely some food for thought there.